Good day, class. This is another lesson on solid shapes. The previous class we dealt with how to find the total surface areas and volumes of different solid shapes. Then we said something about the cylinder, cone, how to find their total surface area and core surface areas, and the same thing with cube and cuboid. Then we also found the volume, how to find their volumes. That was in lesson 1. So today again we are going a little further to how to find the total surface area again and volume of the composite solids. When you are talking about composite solids, a composite solid is a figure that is made up of more than one solid. For instance, a cube and a square base pyramid. You can see there are two solids, but they are being made to be one. A cube and a square base pyramid. Then we can also talk of a cylinder and a cone. So this is another composite solid. Then we also have a cylinder and a hemisphere. Then we also have a cone and a hemisphere. So this is an example of a cube and a square based pyramid. So this is the square base, while this is the pyramid. Then secondly we said a cylinder and a cone. Here is the cylinder, and the upper parts we have the cone. Then we also have a cylinder and a hemisphere. This is a cylinder, then the hemisphere is on top. Then we have a cone and a hemisphere. This is a cone on top, then a hemisphere under it. Now let's take this example. Example 1, the figure below shows a solid composed of a cone of height 15 cm, radius 10 cm, and a cylinder with given dimensions. Calculate the total surface area in terms of pi. Now this is the diagram. We have the height of the cone. We are given the height to be 15 centimeters. Then we have the radius of the cone to be 10 centimeters. Now, since this cone fits on the cylinder exactly, so it means the radius of this cylinder will also be 10 centimeters. Then we are given from this diagram the height of the composite solid, and that is 30 centimeters. We have to calculate the total surface area of this solid. Now, first of all, we have to find the slant height, which is L, this slant height. And using Pythagoras theorem, we can see that our L square will be equal to 10 square plus 15 square. And when you do this, you are going to have 100 plus 225. And this is going to give us 325. Now, finding the square root of 325, we are going to have 5 root 13. Now, we are to find the total surface area, as earlier said. To find the total surface area, we need the curved surface area of this cone. And we also need this cylinder, an open cylinder at one end. So this is 2 pi RH plus pi R square. And when you do this, you are going to have the radius is 10. That means 10 pi. And open bracket 5 root 13, which is your slant height L. Then we have 2h. Our h here, that's the height of this solid, which is 30 centimeters. So 2 times 30 is 60. Then plus 10 centimeters, which is the radius, and that gives you 70 here. So when you do this, you are going to have opening these brackets, you have 50 pi, open bracket, root 13 plus 14. Then close the bracket. So that will be the total surface area of that solid. Then let's go on to look at another example. It says the diagram shows a wooden structure in the form of a cone mounted on a hemispherical base. The vertical height of the cone is 24 centimeters and the base radius is 7 centimeters. Calculate correct to three significant figures the surface area of the structure. Now, first of all, we have the slant heights here. So we have to look for the slant heights. So, and that is L square equals, using Pythagoras theorem, is going to be equal to 625. That's L is going to be 25 when you find the square roots. Okay? Then we have the total surface area of that structure. It's going to be core surface area of the cone. Then we also have the hemisphere. So, and that is going to be 2 pi r square. And adding this together, we are going to have pi r open bracket L plus 2r. Now substituting for pi, which is 22 over 7, times your radius is given as 7. Then your slant height, we got that one to be 25. Then plus 2r, 2 times 7. And when you do this, you are going to have 847.7 centimeter square. Now to three significant figures. That is going to be 848 centimeters square. Now let's look at hollow shapes. When you are talking about hollow shapes, there are boxes and pipes that have spaces inside. So we have, this is a box. You have an example in your house. Okay, this is a box of biscuits. And this is another hollow shape. So which is a pipe. So we have example, you have, look at the pipe you have at home. So the volume of the rectangular box is equal to volume of big box minus volume of small box. And that is length times breadth times height. Then we are going to use small letters to represent that of the small box. Then we have the pipe. The volume of this hollow pipe is going to be pi r square. That is for the external dimension. Then minus pi r square L for the inner dimension. Now let's take an example. An open wooden box is made up of a material which is 4 centimeters thick. The inner dimensions are 16 centimeters by 12 centimeters by 9 centimeters. Calculate the volume of the wood used in making the box. Now the volume of the wood box is length times breadth times height. So that is for the external dimension. And for the inner dimension, you have small letters representing that. So the external minus the inner. For the external dimension, we are told that the material is, the wood box is made up of material which is 4 centimeters thick. And we are given 16 centimeters as the length. So that means this 4 centimeters, you are going to multiply that by 2 and add it to it. Then we have the breadth. The breadth is 12 centimeters for the inner dimension. So the thickness, okay, will make it to be 20. That is 4 times 2, which is 8, plus that 12, that is 20. Then we have the height. The height for the inner dimension is 9 centimeters. Then 4 centimeters thickness, okay, that will make it 13 centimeters. So we are going to have for the external dimension. Then for the inner, The length is 16, the breadth is 12, and the height is 9. Now, when you do this, we are going to have 6,240 minus 1,728. And this will give you 4,512 centimeter cube. Now, example 2. A pipe is made of a metal 2 centimeters thick. The external radius is 13 centimeters, while its length is 16 centimeters. Calculate the volume of metal in making the pipe. Now, the volume of metal pipe is equal to pi r square L. Now, look at the radius for the external dimension is capital letter r square minus pi r square small letter for the inner. Then we have pi L, open bracket, r square minus small letter r square. And your pi is 22/7 times the length given is 16 centimeters. And the radius for the external dimension, the radius is 13 centimeters. And for the inner dimension, we are told 2 centimeters thick. So we are going to minus that 2 centimeters. This is a pipe. It's not a box this time around. So exactly that 2 centimeters from 13. And that gives you 11 square. So we are going to have 22 times 16 times 48. And when you do this, you will have 2,413.7 centimeter cube. Now let's go to what we call a frustum. When you talk of a frustum, this is when the top of a cone or pyramid is removed by a pin, which is parallel to the base of the shape. The remaining is called a frustum of a cone or pyramid. Now, if you look at this shape, it's in form of a cone, but you have this smaller cone which you can remove. Okay, when you remove the top, now the remaining part here, from here to this place, represents the frustum of this cone. Now, using similar shapes, we are going to have r over r, small letter r for this smaller cone. Then for the bigger cone, you have capital R. Then equal to H1. For the smaller cone, you are going to have H1. Then for the bigger cone, the height is going to be H1 plus H2. So which means for using similar shapes, you are going to have R over R equals H1 over H1 plus H2. Then the volume of a frustum of a cone is going to be 1/3 pi r square h minus 1/3 pi r square h1. Remember, this our capital H is equal to H1 plus H2. Now, when you are talking about a pyramid, a frustum of a pyramid now, is just the way we said in the case of a cone. Using similar shapes, the height of the smaller pyramid over the height of the bigger pyramid, which is H1 plus H2, is equal to L, small letter, over capital L. Then the volume of this frustum of pyramid is going to be 1/3 L square, since it's a square base pyramid, L square H. Then minus this 1/3 L square H1 for the smaller pyramid. Remember, your H, capital H, is H1 plus H2. Now, let's take this example. Calculate the volume of a bucket 14 centimeter in diameter at the top, 10 centimeter in diameter at the bottom, and 9 centimeters deep. Using similar shapes, the radius of the smaller cone You know the diameter is 10 centimeters, so the radius is going to be half of that. That is 5. Then the radius of the bigger cone is going to be 7. That is half of this 14, which is the diameter here. So we have 5 over 7 equals h1 over h1 plus h2. Now your h1 is not given, but you have your h2. So you are going to cross multiply. When you cross multiply, you will have 5h1 plus 5h2. 5h1 plus 45 when you cross multiply. Then this is going to equal to 7h1. Then h1 is going to be 22.5 centimeters. Then to get the height of the bigger pyramid, that's going to be h1 plus h2. And your h1 is 22.5. Then your h2 is given, which is what? 9. So you add this together. Then the volume of the bucket. The volume of the bucket is going to be 1 over 3 pi r square h minus 1 over 3 pi r square h for the smaller bucket. And this is going to be 1 over 3 pi, open bracket. The radius for the bigger bucket is going to be 7 square. Then the height is 31.5 minus 5 square times 22.5. So when you do this, you are going to have 22 over 21, open bracket 1543.5 minus 562.5. And this is going to give you 1.0476 times 981. Multiplying this, you are going to have 1027.7 centimeter cube. Now let's take another example. A frustum of a pyramid is 3 centimeters square at the top and 6 centimeters square at the bottom, and is 5 centimeters high. Calculate the volume of the frustum. Now using similar shapes, remember our h1 over h1 plus 2 plus h2 is equal to L over L. And we are given from the question, our h2 is 5 centimeters. Look at it here. Then is equal to, we have h1 over h1 plus 5 equals, our small l is 3. That is the dimension here, 3 centimeters. Then for your bigger L, that is what? 6 centimeters. And when you cross multiply, you are going to have 6h1 equals 3h1 plus 15. And this will make you, it will give you h1 equals 5 centimeters. Then the volume of the frustum of this pyramid is 1 over 3 L square h minus 1 over 3 L square h1. Remember your capital H is h1 plus h2. Then the volume of the frustum of this pyramid is 1 over 3 L square h minus 1 over 3 L square h1. So substituting, this is your L, capital L, 6 square. Then capital H is 10. Then we have small l is 3 square. Then your h1 is 5 centimeters. And when you do this, you are going to have 360 over 3 minus 45 over, and this will give you 105 centimeters cube. Example 3. It says calculate the surface area of a bedside lamp in the form of a frustum of a right circular cone, of which the top and bottom diameters are 18 centimeters and 30 centimeters respectively, while the vertical height is 4 centimeters. Now putting this in a diagram, we are going to have, this is the radius. The diameter is given as 18 centimeters then it means the radius will be what? 9 centimeters, half of that. Then for the bigger cone, we are going to have 15 centimeters as the radius. That is from the 30 centimeters diameter. Then we have H2 given us 4 centimeters. Now using similar shapes, you are going to have small r over capital R equals H1 over H1 plus H2. And this means your small letter r is 9 and your capital letter R is 15 centimeters equals H1 over H1 plus 4. Cross multiply, you are going to have 15H1 equals 9H1 plus 36. And your H1 is what? 6 centimeters. Now we want to find slant height, L. Using Pythagoras theorem, we have L square equals R square plus H1 square. And this means you are going to have 9 square plus 6 square. Now when you do this, you are going to have L to be the square root of 117. And this equals 10.82 centimeters. Now to find the capital L, that is also going to be L square equals capital R square plus H square. And you remember your radius for the bigger cone is 15 centimeters, and that means 15 square plus 10 square for the height. And this gives you 225 plus 100, which is 325. Now L is going to be the square root of 325, which is 18.03 centimeters. Now, the surface area of the lamp that we have to find will now be equal to pi RL for the bigger cone minus pi RL for the smaller cone. Now let's substitute the values we got. For the bigger cone, we got capital L to be 18.03, and for the smaller cone we have 10.82. For the smaller cone we have L to be 10.82. And when you do this, you are going to have 3.1424 for 22 over 7. Then 15 times 18.03 will give you 270.45. Then 9 times 10.82 will give you 97.38. And when you open this bracket, you are going to have 3.142 times 173.07. So this will give you 543.78594. Now when you do approximately, this is going to be, so 2 decimal places is going to be 543.79 centimeters square. Now example 4. A water reservoir in the form of a cone mounted on a hemisphere is built such that the plane face of the hemisphere fits exactly to the base of the cone, and the height of the cone is 6 times the radius of its base. Illustrate this information in a diagram. Then secondly, if the volume of the reservoir is 333 1/3 pi meter cube, calculate correct to the nearest whole number the volume of the hemisphere, secondly the total surface area of the reservoir. Now this is the diagram. So this is the reservoir in the form of a cone and a hemisphere. Now this cone is mounted on this hemisphere, and the base of the cone fits exactly on the hemisphere. So the volume of this reservoir is going to be volume of the cone plus volume of the hemisphere. And the volume of the cone, the reservoir given from the question is 333 1/3 pi. And this is equal to volume of cone. Remember, it's 1/3 pi r square h. And volume of hemisphere is 2/3 pi r cube. And when we change this to improper fraction, we are going to have, and you can do away with the pi. When you factorize pi out, it's going to cancel, so that will go. So you have 1000 over 3 is equal to 1 over 3 r square, open bracket h plus 2 r. And multiplying through by 3, it means you are going to have a linear equation, which is 1000 equals r square, open bracket h plus 2 r. Now from our question, we were told that h, the height of this reservoir, is equal to 6r. And this means that wherever we have h, we can put 6r to replace it. So we have 1000 equals r square, open bracket 6r plus 2r now. And this will be 1000 equals 8r cubed. And from here we can get our r raised to power 3 to be 125 when you divide both sides by 8. And r will give you what? 5 meters. Then we have to find the volume of the hemisphere. The volume of the hemisphere, remember, is 2/3 pi r cubed. Now 2/3, our r cubed is 5 raised to power 3. So you substitute that, 2/3 times 22 over 7 times 5 raised to power 3. And when you do this, you are going to have 5500 over 21, which is equal to 261.90. So approximately to the nearest whole number, this will give you 266 meter cube. 262 meter cube. Then we are asked to find the total surface area of the reservoir, and this will be equal to cos surface area of cone plus cos surface area of hemisphere, and this will be half pi rl plus 2 pi r square. Now remember that your h is 6r and your r is 5, so which means your h is going to be 30 meters. Then from the diagram, your slant height L square is equal to, using Pythagoras theorem, that will be equal to 30 square plus 5 square, and that is 900 plus 25. So which is 925. So L is going to be 30.41 meters. Then the total surface area of the reservoir is going to be 22 over 7, which is times 5 times 30.41, and this represents the cos surface area of the cone. Now the cos surface area of the hemisphere, that will give you 2 times 22 over 7 times 5 square. Now this is going to give you 477.87, and this will give you 157.14. Adding this together, you are going to have 635.01. So approximately to the nearest whole number, we are going to have 635 meter square. Now that is how far we can go on lesson 2 of solid shapes. So we have the test practice here. So number 1 to number 5. This number 1 says calculate the volume of the material used in making a pipe 20 centimeters long with an internal diameter 6 centimeters and external diameter 8 centimeters. And number 2, it says the solid is a cylinder surmounted on a hemispherical bowl. Calculate its total surface area. Then 3 says find the volume of the solid in question 2 above. Then 4, the diagram shows a cone with dimension of its frustum indicated. Calculate the height of the cone. Then 5, the diagram, which is a pyramid, the diagram shows a pyramid standing on a cuboid. The dimensions of the cuboid are 4 meters by 3 meters by 2 meters, and the slant edge of the pyramid is 5 meters. Calculate the volume of the shape. So thank you. You can subscribe for more of our lessons on the YouTube. So stay safe and stay healthy.